section on the structure of the Earth, the internal structure of the Earth, normally done in fourth form. Now, the Earth comprises of three distinct layers: the core, the mantle, the crust. Right? Now, the crust of the Earth contains two sections: continental crust, oceanic crust. The crust is where we live on. Right? So even though we say, but we don't live on the ocean, it's still comprised of that section that comprise of where we live on, or the surface of it. Because the water of the ocean is on the oceanic crust. All right. Now, continental crust is about 10 to 70 kilometers thick. It's less dense than the oceanic crust. It is said to be younger than the oceanic crust. The oceanic crust is dense and thick, right? And it's said to be older than the continental crust. All right. How do we know what the Earth is made up of? We know what the Earth is made up on through these processes, or through these research. One, geophysical survey. Two, seismic, has to do with earthquakes. Gravity, we know gravity exists. Magnetic and electrical geodesy. You know, all of these things are how we comprise, our scientists comprise to have an idea of the structure of the Earth. All right. Now, acquisition, land, air, sea, and satellite. Geological surveys, fieldwork, boreholes, mines, etc., etc. These are how we know what the Earth is made up of. So what is plate tectonic then? That's the question. Now, if you look at a map of the world, you may notice that some of the continents could fit together like pieces of a puzzle, right? So it seems as if they break apart and they can always be put back together. Now, the Earth crust is divided into 12 major plates, which are moved in various directions. This plate motion causes them to collide, to pull apart, or to scrape against each other. Now, to collide, converge, convergent. To pull apart, divert, divergent. To scrape against each other, transform, transform plate margin. Now, each type of interaction causes a characteristic set of Earth structures or tectonic features. The word tectonic refers to the deformation of the crust as a consequence of plate interaction. So tectonic means the Earth crust change or deform because of tectonic movement or tectonic forces. Now, if you look at this thing, you can pay attention to this. Pause the video, look at these plates, because in your test, you'll normally see this diagram. Whichever test you even see, so you can see this diagram where they put A, B, C, and tell you to name the type of plate here, name the type of plate there. So it is best to pay attention to this diagram right here. Now, what are tectonic plates made of? Tectonic plates are made of rigid lithosphere. Lithosphere is made up of the crust and the upper part of the mantle. As you can see in the diagram, the crust surface where we live on, upper mantle, that section below the crust, mantle, then you have the upper mantle, the mantle, which is the upper mantle is less molten and more solid. The mantle is somewhat molten in its nature. The outer core, it is said to be iron, and the inner core is said to be iron and nickel. All right, well, you can check these out in more detail. What lies beneath the tectonic plates? Below the lithosphere, which makes up the tectonic plate, is the asthenosphere. All right, big word there that I want you guys to check out. What is the asthenosphere? That's a word you will see in your exam as well. Now, plates of the lithosphere are moved around by underlying hot mantle convection cells. Now, if you look at this, the heat coming from the core, where the inner outer core melts the rock within the mantle, creating what they call molten or magma. Remember, it's magma when it is down in the Earth's crust, or down below the Earth's crust in the mantle, it's magma. When it reaches the surface, it's lava. So this core melts the rocks within the mantle, which cause a molten or liquid form. Now, when the heat from the core and the mantle reaches the surface, right? As you can see with the arrows, it goes up and then it turns in a circular motion. Now, this circular motion helps to push the Earth's crust along. Now, in some areas, the circular motion, when it meets the crust, the undersection of the crust, it pushes it like a ship and water, right? And in some areas, it pushes it together. In some areas, the same convection current pulls it apart. In some areas, the same convection current slides it past each other, right? Creating movements within the plates. Supercontinents. Now, what happened at tectonic plate boundaries? At tectonic plate boundaries, three distinct tectonic plate boundaries, several things occur. One, divergent, plates move apart. Two, convergent, plates move together. Three, transform, plates slide beside each other. All right. At a divergent plate boundary, as you can see here, it says divert. Divert means to move apart. So when the convection current comes up from the mantle, slides along the undersection of the Earth's crust, pushing them apart, then this create gaps within the Earth. Now this gap allows magma from the mantle to rise to the surface, creating new features and new landforms. All right. In some areas, it is called seafloor spreading if it occurs under the sea. Now, spreading ridges. As plates move apart, new material is erupted to fill the gap. Age of oceanic crust. Now, Iceland, an example of continental rifting. Iceland has a divergent plate boundary running through its middle. And as you know, Iceland earthquake and volcano occurs even a couple of years back. They had volcanic movement and eruption occurred there because the plate is constantly moving apart. If you can see this, you have the North American plate pulling one side, the Eurasian plate pulling one side, creating a gap in the middle. And from this gap, we have molten materials from the mantle reaching the Earth's surface, creating new landform when this mantle cools and hardens. Convergent boundary. There are three styles of convergent boundary. You have continental to continental collision, where two continents meet and collide, creating what they call folding or fold mountains. Yeah, continental and oceanic collide. When continental and oceanic collide, then the oceanic sinks under the continental, creating what you call a subduction zone. Then you have oceanic meets oceanic collision. When two oceanic plates meet, the older oceanic plate will subduct. Right, so at a convergent boundary, if a continental crust meets a continental crust or a continental plate meets a continental plate, it folds or uplifts, creating fold mountains. If a continental meets an oceanic, the oceanic is older, so it sinks under the continental, creating a subduction zone. While if an oceanic meets an oceanic, the older oceanic will subduct, creating a subduction zone as well. Now, continental crust forms mountains, and like we say, fold mountain, Andes, Rockies, Alps, Himalayas, fold mountains. All right. As you can see here, continental crust meets continental crust. You have upliftment, you have upliftment where it bulges or push up, and it creates what you call folding. Now, as you can see here, one goes down, one comes up, fold over it, creating these mountain ridges. Himalayas, example of a fold mountain or a mountain formed from the collision of two continental crusts. Continental meets in oceanic, called subduction. As you can see, one going down, one going over. You have a subduction zone right there. Subduction also occurs, oceanic lithosphere subduct beneath the continental lithosphere. Oceanic lithosphere heats and hydrate as it subsides. The melt rise forming volcanism, example the Andes. So when the subduction occurs between the oceanic and the continental, you have volcanoes along these borders. or along the line or the line where the two plates meet. Oceanic plate means oceanic. When two oceanic plates collide, one runs over the other, which causes it to sink into the mantle, forming a subduction zone. The subducting plate is bent downwards to form a deep depression in the ocean floor called a trench. For example, the Mariana Trench is an example of two oceanic plates meeting and one subducting. All right, these are some of the weird animals form are found along these subduction zones under the sea, close to the trenches. Because these are very deep areas, all right? So animals have to be adapted to such an environment in order to survive there. Transform boundaries, where plates slide past each other. So when plates slide past each other, you have a transform boundary. For example, your San Andreas Fault. Now the Earth's plate, pay attention to this diagram as well. All right, to see where the plates are, all of these things, guys. You will see these things again. Any map related to plates, once you're doing plate tectonic, your teacher is going to give you a map. She's going to want to know, can you identify the plates? This is an activity, we can do this online, so you can decide if you want to do this. Volcanoes and plate tectonic. What's the connection? Easy. From the top of our head, plates move apart, magma reaches the surface, volcano occurs. Plate move towards each other, one subduct, the pressure of one causes cracks within the Earth's crust, magma from the mantle reaches the surface, volcanoes are formed. So let's see what the text say. Pacific Ring of Fire, an active area of volcanic activity. So volcanism is mostly focused at plate margins, and we know that because there are activities there. Pull apart, subduct, cracks created, magma reach the surface, lava, volcanoes are formed. The volcanoes are formed by subduction, rifting, or hotspots. All right. Now, at the Pacific Ring of Fire, you have hotspot areas. These are cracks within the surface. As the Earth's surface moves, sometimes there are cracks that occur, and these cracks they form volcanoes. For example, in Hawaii. Now, every time the Earth's crust moves slightly, the crack moves to a different section. And it is not moving fast; it's moving slow. So each time it moves, it creates a volcano wherever it is. So that's why you have those small volcanoes all over Hawaii because of a hotspot area that constantly move as the crust itself moves slightly and slowly. So what are hotspot volcanoes? Hot mantle plumes breaching the surface in the middle of a tectonic plate. For example, we say Hawaii is an example of that. Tectonic plates move over a fixed hotspot, forming a chain of volcanoes, like I was saying before. So you have a hotspot area. As the plates move over it, as the plates move over that area, it causes cracks within the crust, and these cracks allow volcanoes to be formed wherever the crack exists. Now, volcanoes get younger from one end to the next. Because once the crack move on, or once the Earth's crust move on, then there's no more volcanic activity occurs, and that volcano becomes dormant or dead. All right? Earthquakes and plate tectonic. What's the connection? As with volcanoes, earthquakes are not randomly distributed over the globe. At a boundary between plates, friction caused them to stick together. When built up, energy caused them to break. Earthquakes occur. Where do earthquakes form? Earthquakes are formed on these areas or at these areas. At oceanic ridges are divergent boundary, and trenches are deep sea trenches. They are formed along transform boundaries as well. Plate tectonic. The Earth is made up of three main layers: core, mantle, crust. Plate tectonic summary. On the surface of the Earth are tectonic plates that slowly move around the globe. Plates are made up of crust and upper mantle or the lithosphere. The lithosphere is the upper mantle. There are two types of plate. There are two types. There are two types of plate, and there are two types of plate and three types of plate boundaries. Volcanoes and earthquakes are closely linked to margins of tectonic plates. All right. So this is a simple just an overview of plate tectonic. When you get a chance, you can listen, you can read, you decide, slow the video down if you're studying and you don't have enough notes on plate tectonic, and go through. It is very informative. I try to run through it as fast as I could to ensure that you can listen it over and over. For those who are good listeners, for those who are readers, you can always pause it, slide and read. You decide, and you can hit a subscribe if you want to find more information on geography. We have been doing a lot of stuff to see if we can get the information out there for those who don't have it in order for you to go and pass your Csec exam. So have a wonderful day. Subscribe. Let us see what else we bring out. Let's see what else we have. Okay.